Cool. So, hello everyone. Thanks for joining us today. I hope all of you can hear us fine. There's a 40-second delay between our discussion and your comments, but keep posting your suggestions there, and I will keep reading them. So, the idea today is I will be reading out a controversial statement, and our panelists would either vote with a thumbs up or thumbs down. And yeah, we don't want anyone to do this. We want them to either be thumbs up, thumbs down. So I think Konrad is unhappy with that, but that's the idea. So regarding everyone who's on call, I'm Surya, joining us today. I hope all of you can hear us. Someone has their crowdcast open. We'll have to close that. Your comments, but keep posting your suggestions there, and I will keep reading. I think Adrienne has crowdcast open. The idea today is I will be reading out a controversial statement, and our panelists would either vote with a thumbs up or thumbs down. And Adrienne, is it possible for you to close your broadcast? Thumbs down. I think Konrad is unhappy with that, but that's the idea. So regarding everyone who's on call, I'm Surya, joining us today. I hope all of you can hear us. Someone has their broadcast open. We'll have to.
So yeah, are you sure that's not you?
Let me kill that.
Yeah, it might be Surya.
Yep, it's perfect now.
Sorry about that.
Sorry, yeah, we're working around a lot of things, so just bear with us today.
Hang on, I don't actually know how to vote. How do you vote? How do you get a thumbs up?
Yeah, just with
just
your
actually with my thumb. Okay,
Yeah.
So looking for the thumb button.
Yeah, so my name is Surya. I'm a master's student at McGill working with Blake Richards, and I'll be moderating the panel today with Konrad Kording from University of Pennsylvania, Adrienne Fairhall from University of Washington, Guillaume Lajoie from University of Montreal, Karim Jerbi from University of Montreal, and Irina Rish from University of Montreal. And so let's get right into it. And it seems like everyone can hear us fine, so that is great. Okay, so let's start with a more non-neuro AI question. How many of you think, so this is the statement, virtual conferences are better than normal conferences? Either vote yes or no.
Can you please repeat the question?
Are
heard it
virtual
twice, Surya.
conferences better than normal conferences?
There's pros and cons.
I can't hear the question.
Oh, you can't hear the question, Karim?
No, look,
Yeah, there is
I
lots of
hear you
background
twice,
noise.
Surya. It seems that you are active on our chat twice, and we can hear you.
Oh, you hear me twice.
That might indicate that you also have Crowdcaster running somewhere. Have you checked?
Yeah, exactly.
Oh, that is Konrad, you're awesome. You figured it out. Oh,
But maybe you have to.
It might be Karim that has it.
actually, I don't have Crowdcast running.
For me, it's all good now, so I'm good to go.
Oh, do you still hear me twice? Do you still
Nope.
hear an echo? Okay.
Nope.
Weird. I didn't change anything. Okay. So yeah, let's move on to the neuro AI questions. And so we vote and then we debate. So will we ever reach human level intelligence? Will AI ever reach human level intelligence? Okay, so Irina is disagreeing here, so I will let her start. Why do you disagree?
Because I think you can asymptotically try to get closer to it, but you will never reach it. Well, why? Again, it's a subjective opinion, but I think it's just a little bit too complex for us to be able to really model it in its full complexity, at least in any foreseeable future. And it's hard to say what is going to be in not unforeseeable future, but I'm just trying to be a bit more realistic.
Anyone wants to respond?
Yeah, so let me, I mean, like I thumbed up the statement. So let me maybe highlight why I think that we will not only reach human intelligence, but surpass it. So there are, let's first highlight what biological intelligence has ahead of us. So biological experience has basically over evolutionary timescales gained through all kinds of situations billions of times. So it will be very good at those things. But in a way, when we talk about like transhuman intelligence, we're talking about like harder problems that aren't just emulating things that we've done in the past. And when it comes to those things, we have a history of humans not being so good. No, we thought that it was amazing that we could multiply numbers. And then we figured out that that's actually pretty easy with relatively simple machines. And then we thought that, well, we are we are the animal on this planet that can play chess, and where did that leave us? And then we at least believed that we would be like really good at object recognition, and you know where this is going. And sure, you can kind of point out there's still tasks that are left, but in principle, the compute that you can get out of silicon systems is better than the compute that you can get out of meatballs. So that's why I think that in the end, for all the tasks that we can define, and maybe beyond that, we can go further with artificial intelligence. That might take thousands of years, but like at least long term, I'm positive we'll get better than biology.
I'm not sure we need even thousands of years. I think part of the issue is how we define the question. You know, do we mean that we want to replicate what it's like to be human? That's a different thing. And we may not do that because we're full of all kinds of hormones and chemicals and stuff that make our experience different. But, you know, I think Konrad has pointed out just a few cases we're already way beyond superhuman intelligence. So I think it's of course we will be able to create superhuman intelligence. Will we bundle it, or will it become bundled in a thing that resembles a human? I think that's a completely different question.
And Karim wanted to, yeah.
I said, yeah, I said thumbs down, but exactly for the same reason that Adrienne was just mentioning. I think it hinges upon our definition of intelligence. And if I take it in the broader sense of intelligence, for example, in human intelligence for me would also go as far as including things like emotions, creativity, consciousness, metacognition, meta-reflection. Many of these, we do have sort of toy examples where we can see them, how they could fit into an AI system. But I think, again, depends on our definition. And so it's like many of the questions that we are sometimes are ill-posed by definition. So if we define on it, if we come back to the notion of performance as being the key here, then we might say in many tasks we will outperform human capabilities. There's no question about that. But
So
it's not just performing machines.
We'll let Guillaume take it, and then quick responses from Irina and Konrad.
Yeah, so I just wanted to build on this.
We cannot hear you.
Oh, okay. Sorry. If you cannot hear me, this
Still cannot hear you, sorry.
1 second. It's going.
No, zero.
We
Is
can hear
this
you
better?
very softly. Yes.
Oh, okay. So I was just going to say, coming back to Konrad's first remark and bouncing back from Karim's remark, is that I think evolution gave us some constraints such that we have, you know, a sensory system, bodies, we have social behavior, and a lot of the things that we've learned to do with respect to these constraints are sort of trivial, and there's no natural pressure to artificial intelligence to meet these things. And so I would just want to say that it's likely that everything we try to do that matters with artificial intelligence, we can possibly go beyond human level intelligence. But all the quirkiness that comes out of human behavior, there's just no incentive from whoever builds AI to emulate these things up to a certain degree. So I think it's very, it depends on the sort of energy of the research that's put into it to a certain extent.
Yeah, Irina.
Yeah, so actually the point that Guillaume and Karim made are quite related to what I wanted to say. And to reply to Konrad, The examples of superhuman game playing are amazing, but again, we didn't define what we mean by intelligence. And beating human champion in whatever game is not intelligence. It's just being very narrow at particular task and using, well, lots of compute to achieve this task. And we don't have any system so far, nobody, neither DeepMind nor OpenAI, although people would like to, that would be able to be at the level of mediocre human, not beating anyone in chess or Go, but just being able to learn how to play chess, learn how to play Go, learn how to translate from, I don't know, English to French, then maybe learn how to paint and keep doing that and be able to do all of that and be kind of broad and not narrow. It's not even AGI. We don't even have that. And I'm not even totally sure that with the current tools, we'll be getting there. So this is even like intermediate holy grail, and we are far from having versatile AI at the level of mediocre human. Forget about beating human. And my second point is that, again, related to what Guillaume mentioned and Karim mentioned, in terms of modeling emotions and in terms of constraints during evolution. I think the natural intelligence developed in a way to survive, to maintain homeostasis. So if the intelligence emerges as a homeostatically driven behavior, then maybe we should be using or developing models, algorithms, and tools along those lines. So I'm essentially referring to Antonio Damasio's famous point about homeostatically driven, homeostatically motivated intelligence. And I believe that has a good point. The agents should be vulnerable. They should be potentially dying. They could be killed. They will have constraints. And in order to survive, in order to maintain their homeostasis, as a population, not a single agent, they will be developing what we call intelligence. And that goes all the way before even nervous system and the high kind of level organism. It goes all the way to bacteria, again, referring to Michael Levine and, well, of course, Blaise Aguirre. So I like those plenary NeurIPS talks from 2018 and from 2019. And I keep repeating that it's always worth rewatching those two talks. You know what I'm referring to. I think that maybe the answer is maybe if we significantly reconsider how we model intelligence.
Can we get a quick response from Konrad before we move on to the next statement?
Yeah, I was just going to say that there is an important meta component there, where you can say, like in our explanations of intelligence, a lot of it relates to the environment and the fact that we basically solve lots of problems one after another. And evolution is a meta-learning algorithm. So, and I think in machine learning, we see really an emergence of powerful ideas on meta-learning, on learning to learn. And that might be one of the things that basically allow us to unify those perspectives. Not like what we refer to about the problems in the world are things that we might be able to set up in simulation environments. And I think we'll need those things if we want to have intelligence that feels more human-like.
Yep.
Maybe one quick thing I'd like to comment on this is I also think beyond like things like emotions, creativity, and things like that we mentioned at the beginning, I think also interaction, A, with the environment, but B, with other agents. In other words, social intelligence, the fact that we are not by ourselves here, that is part of what we call intelligence. So if that's what we want to refer to as being the milestone to achieve, I think that's going to be much more complex. But I mean, I think we just need to keep into consideration the fact that there is an intelligence that arises from a group of interacting agents, and that might be beyond what one unique agent is able to do. And I think there are models of how that has been transposed into AI, looking at swarm intelligence and things like this. But I think that is a very interesting venue for future research.
Yeah, and this closely relates to our next question, which is, will machines be conscious at some point? Vote either yes or no.
Oh.
That's-
Yeah.
You can define how you're using consciousness and then respond to the claim.
So yeah, if I may say, like a lot of these questions, we can always have the escape route of saying, well, it depends how you define whatever, right? So I'll try not to fall in this pattern, but I believe tying up to the last point of this discussion, I think there are very useful elements that are associated with consciousness that are imperative to explore that might solve tangible problems that we have in AI, such as generalization properties, so on and so forth, right? But I believe that it's unclear to me that most of these ingredients will be used in the same measures, for example, as there is in a human brain or an animal. And so even if, yes, the ingredients might be used, and I'm thinking about attention principles and use of memory, and the list is long. The fact that might be built differently might not necessarily lead to the secret sauce of consciousness. Actually, I would doubt that would be the case. And so my point is, ingredients definitely leading to consciousness itself, just as an emergent principle. I think it's less likely, just because we might use them in different quantities than in the human brain. If that's my position.
I think I would come back to what I said before, is that I think there can be a version of consciousness that is a machine one, that we may feel different than it feels to be human, but may have some of the same properties, an internal model of self that allows one to report about one's state and one's condition and interact with others and build models of others. I fully believe a machine can do that. Whether it will feel like it feels to have sensors and a gut and hormones and anxiety, maybe not, right? It may not feel the same way, but I think it could be equivalent in terms of the key properties of what we think consciousness is.
But I think it's a very useful exercise for us to ask which of the things that we apply the C word for are meaningful and implementable, and we can do things about it. And there's some things that are really obvious. Do I want a record of my past thoughts? Yes, I do, because there's some really bad thoughts that I had in the past that I can now basically make sure that in the future I don't follow that path of thoughts again. And that's super useful. And there's a lot of these aspects. Do I want to maybe think of the world in terms of causal concepts? Yes. Do I there's a lot of things that are part of consciousness for us that we should build into machines. It's just that, to me, the C word is generally associated with superficially talking about non-computational things.
Yeah. Moving on. So a little bit of background before we move on to the statement. There are different resolutions at which we can model biological neurons. Based on their output, we generally have two major choices. One is to have higher resolution. One high resolution choice is to model the spikes of neurons, and another choice is to abstract that out and use firing rates. So the statement I want you guys to respond is spiking nature of neurons an important feature for intelligence? Yes or no? Konrad, I'm waiting for your yes or no.
I think he's frozen. That's a good thing.
Yeah,
All
yes,
right,
for some reason
run
my camera's frozen. That's bad.
Guillaume, I'm playing devil's advocate. What are you doing?
So can you see me again? Am I?
Not yet, you're still frozen. Just tell us, we're dying to know. Yes or no, Konrad?
Yes.
Oh, it's very interesting, because I was expecting a no from most people on this question, because at least presently we use the models that we built to approximate the brain are not using the biological spiking detail. I think we lost Konrad.
Oh, he's
But
back.
Konrad is back. Okay, who feels strongly about this and who wants to respond?
I guess I would take a maybe more nuanced role than spikes. I would like to more say low-level biophysical properties of neurons. And that could include lots of different things. That could include the way ion channels interact with neurotransmitters and neuromodulators. That could include complex dendritic properties. You know, maybe if spikes are probably important in some particular circumstances, but all that deep underlying behavior that neurons have are fundamental to the way brains work. Do they need to be built into an intelligent system? Probably not. I think there are other ways of achieving those things, but they won't work like the brain does. They won't work with the same kinds of dynamics.
Yep, Konrad.
So there's certain problems, of course, that spikes can solve for you, which is spikes are 0 versus 1 event. And you can say, if I want to know if I'm a neuron somewhere in a big network, and I produce spikes, then I can use that to understand what's my causal influence on other things happening in the network. So in that sense, spikes may be a way of making a certain causal problem much easier. So in that sense, I think there might be direct computational roles for it. In fact, roles that we might want to build into artificial systems.
Guillaume? Yeah.
Yeah, so everybody was voting yes, and it's funny because I'm, you know, for a long time, I still do think that spikes are very rich and important to how the brain works. But, you know, and I really like Adrienne's response, that says that in essence, there's many little mechanisms at the level of neurons that we don't understand, and I think have a very important role in learning that we need to grasp, and that's likely to help artificial intelligence. But again, if the question is, can we reach, you know, do we need spikes inevitably to advance AI? I don't know, because to a certain extent, it's the spike is again an evolutionary trait that you know has that responds to constraints that we might not have in computers, and I'm not certain that a non-spiking artificial network can be generically limited as opposed to a spiking one.
Yep, Konrad.
But what if we do have those constraints? Now, like I'm not sure if we don't have them. Now, like if we have a digital system and we zoom all the way in, there is something that is very close to spikes, namely a process that either drives us towards exactly 0 or towards exactly 1. And like spiking the way the brain has implemented is the same idea. It's like an all or none event. And these kinds of ways of encoding things allow you to transmit information for very long distances in a system that's otherwise noise dominated.
But there's also heaps of other stuff going on in the brain, which is super analog, and that is not done by digital systems, and is probably also adding incredibly much to the richness of computation, and maybe in ways that are very inefficient to do in a digital framework.
Irina, and then Karim.
Yeah. So I really agree with Adrienne, and the point is not necessarily maybe spikes per se, but especially I was a bit surprised by Guillaume's response, because I think we all agree that, say from information theoretic point of view, so to speak, the environment, the real environment, only exists in time. And it's very kind of rich environment, and things that happen and different sequences of things that happen, I hypothesize, can be only encoded by an equally rich dynamical system that has notion of time. And a simple example, I mean, the classical argument is if I give you a vector of hidden variables, and hidden variables say binary, like how much of the different environments, how many environments can you encode? It's like 2 to the n. If I allow you to encode using sequences, it's already n factorial. And if I allow you to use time to encode, you have much more capacity for encoding environments. And I believe that the complexity of the encoder of the brain, in this case, although it doesn't have to be brain, it could be any lower level system, even not neuronal, but cellular, with bioelectric communications. The complexity of that system should match the complexity of environment. And therefore, if we want to model this environment, we probably will need to have some notion of temporal, dynamical very much
But-
coupled system.
I want to reply to Irina real quick, because with that logic, an analog system, say where we track a hidden state as a scalar variable, is much more complex than a binary of on or off, right? Like if I think of the dynamical system of a rate model, it is to a certain extent contains more information for an infinitesimal time point than binary states. And again, I think it's likely that this binary representation of information is a constraint on the wetware, like the meatball we have to deal with. But from an information theoretical point of view, that's what leads me to not be so certain. There is more information in a scalar hidden state. Don't you think?
No, I mean, how would it be more information in, okay, so you only have 2 to the n binary vectors of length n, and then in analog space with sequences of firing and time between those sequences, you have much more representation power, don't you?
But what about sequences of continuous numbers? I think that's what Guillaume
Exactly.
Yeah, okay.
Yeah. Instead
So-
of having like the vertices, you have the cube, right?
No, that's exactly what I'm saying. I said, for example, if they're binary, even if they're binary, you
Yeah.
already see why you need sequences, and maybe not just sequences, but time
Okay.
between the
I
events.
see your point. But
And then
yeah.
they are not binary. Binary was even simplification.
No,
So-
but they're factorial. But then again, the same is true if you have a dynamical system in a continuous times. But
Yeah.
again, I think it's an interesting discussion, mathematical discussion to push the limits, right, of these things.
Anyway, it just feels that the real world has inherent notion of time, and that should be reflected in artificial system. And by the way, again, it doesn't necessarily have to be full focus on trying to model the brain and neurons, because again, I'm biased. I really like Michael Levine's work on bioelectric communication, as all of you know by now. But I think it was a good point, because those systems are non-neuronal, and yet they have high level of adaptation, very good memory. Basically, this morphogenesis, remembering how the system's supposed to evolve and into what. So there is memory, there is adaptation. That's intelligent behavior.
Right.
No neuron involved.
I will give Karim a quick chance to respond.
Yeah, so I think this is very interesting. I come from a neuroscience perspective, and also this is in line with what Adrienne was saying earlier on, and what we saw from Eilif's talk today about the brain being more complex than we would like it to be for us to model easily. The complexity also arises from the fact that yes, neurons do complicated stuff. It's complicated to model them, but we also have populations of neurons, ensembles of neurons, and there is coding at the level of ensembles. So this, again, I might come over as a socialist because I want to put a lot of people together now and putting a lot of neurons together. But I think, so we study a lot in our lab oscillations. We look at oscillation dynamics, the role of beta oscillations, alpha, theta, different frequency bands, gamma, their role in binding. And there are a lot of work that shows like decoding behavioral tasks. Sometimes you get to better performances when you're looking at the LFP and the population level than you would get at a single unit, if you're not maybe with the right units. And it's a long debate to have, and we're not going to solve it today. But with regards to the question, I think that's another level that hasn't been looked into sufficiently when moving on to these AI and neural networks. How do we involve our understanding at the ensemble level of coding, and how can that be more useful for development of next generation neural network?
Yeah,
Dynamics
I think this
must
idea
be
of
multi-scale.
modularity is important. Yeah.
Yep. So we have one more question and then one more statement, and we'll be moving on to audience statements. So audience, you can put your questions in Ask a Question tab, and people will upvote, and I'll ask the top question to our panelists. So the next statement is, does the brain optimize cost functions?
I think
Ish.
I will
okay.
say that you did not ask, does the brain only optimize cost function? So I'm, as far as it's not a hermetic question, then I'm good. Yeah.
And you also didn't ask the question: does the brain optimize one cost function? For which my answer would
yeah.
Yep.
Yeah, so
Well, in my
it's
case,
not
it
about
depends
one
on days.
cost function.
Yeah.
There are some days where my brain does that, and other days I wake up and it's just not doing that.
Can my answer be in a quantum state?
Sure, if you can explain it, yeah.
Yeah, I'll keep doing that.
So Konrad, it
I
seems
think
like
like
some
any
people,
kind
yeah.
of model, you can draw a box around a subset of things that happen and build a model for that, which that's the right description. But is that the right global description? Who knows? But I don't think that matters. I think we can find lots of subsystems and sub moments, of dynamics for which that's a very appropriate model.
Yeah.
And so maybe I should give a little background to why my answer would be yes to that. And in a way, it's a pragmatic answer. So the brain's learning algorithm is some complicated function depending on all kinds of things, all the ugly biological reality that Adrienne related to earlier. There's all that in it. So in a way, the idea that we can look at pieces and build a research program around, let's find cost functions that approximately deal with that feels very attractive because it allows us to go into a much simpler space. And you can say the learning algorithm that the brain uses is some dynamical system in a very high dimensional space, but a lot of these systems have the properties that they eventually kind of get towards a stable point that kind of depends on the prom. And if you want, the environment is the prom. So in a way, it is a bet on my side on the hope that at that level, the brain might be understandable, even if potentially the underlying dynamics itself cannot be understandable. Then you can say you can always view the dynamics of a learning system as one part that optimizes something and another part that's orthogonal to it that just basically does stuff. Now, the second part, maybe I don't overly care. No, like it doesn't affect if we get better at it. And the other part is also incredibly complicated. Whereas like this optimization component, even if it's just a part of it, it comes with the promise of us making progress at understanding it.
Anyone wants to respond? Yep.
I was rather kind of responding to the original question. Again, yes and no, depending on whether you're looking at particular subsystem, and it's sometimes yes, but it's rather the question of like, at what level you're looking at the system. So again, I really liked a particular slide in Blaze's recent talk at Neurons, where he shows this vector field of again and says, look, there is no single objective function which could have possibly be optimized by that. So what's going on? You have multi-component system of interacting elements, and this behavior kind of evolves. And even if each component may be optimizing certain function, you can assume so, although each component or cell is yet another dynamical system at other scale. So even if you assume that one is optimizing function, then the combination of this is kind of game. It's not necessarily that the system is optimizing any specifically written down objective function per se. The question is, I think, like if you look at the behavior of the system, can you at least say that there is a single objective that's being optimized by that? But that's kind of a hairy question. One thing is clear, that quite often you won't be able to write it down clearly. And that's the same point that Jeff Clune and Ken Stanley and others are doing with this novelty-driven search and other approaches. Kind of yes and no, you can say that in a sense you can put novelty as a part of objective, but it's not always easy to express it actually as a function. Yeah. So it's just a rather different perspective. You can look at the evolving behavior of multiple components at multiple scales, where each component is yet another subsystem. And whatever happens with that, And rather than saying that we will define well-written mathematical objective and try to optimize that.
Yeah.
So that's why I was like that.
Yeah. If I might add to this conversation, I think the big challenge in thinking about the brain as minimizing errors of some sort is to think about this modularity of cost function, right? Like, it's very unlikely that learning in the brain is end to end. In the same way that we train most deep networks or artificial networks, although this is changing slowly. But the idea of having interacting modules of the brain, but also interacting cost functions that are distributed in some complicated way across these different modules is likely what's happening in the brain. And as you pointed out, right, like, and as Konrad spoke of, the idea of orthogonality or interaction of cost functions of error signals is likely very complex, and I think important to understand, at least working principles of them. And so I think, yeah, there are cost functions in the sense that ultimately they combine to us not wanting to die, and that's what evolved the brain or to survive to a certain extent. So, but like how it decomposes and how anatomical constraints and physiological constraints are playing a role in this decomposition is the big question for neuroscience here, I think.
Yep. So we will move on to a few audience questions. So the top voted question is, what does it mean to be intelligent? Who wants to take this?
Well,
Yep, Irina.
Again, I mean, by no means, I'm not claiming its definition, but there are all the popular quotes that the ability to adapt to the environment is a key feature of intelligent behavior. So you could say that basically the interplay between being able to adapt and being able not to forget. So some proper combination of memory and ability to adapt, but again, for what purpose? So this thing about homeostatically motivated or homeostatically driven intelligence is, well, I would call a system or a population of systems intelligent if they will have to survive in a series of environments and they manage to do so. If they able to survive in changing and sufficiently challenging various environments, they adapted somehow, well, you can say that was intelligent behavior, but it's kind of definitely applies not necessarily to high level intelligence. It's like even low level intelligence of living organisms.
I would hate to make a definition that ruled out Ed Witten, who may not be able to survive in arbitrary environments, but does incredible, physics, right? So I feel like we keep redefining intelligence to rule out machines, right? So it's not intelligent to just win chess, whereas we used to glorify people that won chess as incredibly intelligent. So I would like our definition of intelligent to both reflect extremely high skill in any given area, as well as these more broad-ranging ability to adapt. I think we can be too quick to just anything we now know how to do is no longer intelligent, right?
Yep.
So from that end, one thing that strikes me is as very unique. Well, not unique to unique to intelligence in animals is the ability to solve problems that one did not see before, right? So the component of creativity that likely builds on acquired skills across a broad range of different tasks or environments, and being able to coordinate these things in a novel situation. I'm not just talking about generalization or transfer learning to a certain extent, but really the coordination of an acquired set of skills to solve an unseen problem. I think this is very much tied to what we intuitively think about level of intelligence, right? Like if you're an educated person, you'll be able to figure out how to open a bank account, right? If you're a potato, you'll likely not do that, right? But there's this idea of novelty and of creativity that hinges on expertise that I think is important to intelligence.
Karim and then Konrad.
I think, from my point of view, biological definition of intelligence is going to be rather straightforward, because basically it's going to be doing anything it takes to survive. And that would include many things. So ability to adapt is going to be one of them. There are many, many more, right? But what I think is more interesting is that I think we have now the opportunity to redefine what we think is supposed to be intelligence. And I think that even from an AI perspective, we can imagine that we would like to think of an intelligent AI in that sense as being, for example, an AI that's going to take into account social justice, an AI that's going to take into account our impacts on the environment, an AI that's going to be able to self-reflect and see when maybe what it's doing is going to be detrimental to other agents or to other human beings or things like that. So we can redefine that. I think that's an opportunity we have, and then would allow us to even minimize these discussions, because say, well, if we define an ideal intelligence as being this, then we'll also have less arguments about what it really is. But biologically, I think it's rather straightforward, more or less.
You may be bundling morality and intelligence together in a way that's a little, which I think in terms of ethical AI design, I think is a great idea. But whether that really gets back to the original question of the definition of intelligence, it's unclear.
I agree.
Good point.
If I may comment, I think the ethical and moral intelligence, again, can naturally emerge when the agents will be vulnerable and therefore, kind of have feelings which are, according to Damasio, are just kind of a more evolved way of sensing not just environment, but sensing themselves. So once they have that notion, they may develop compassion, and morality and ethics will just kind of follow from that. You don't have to specify it as a separate set of rules. And you don't have to make the artificial system follow those constraints. It will follow that, just like, the mammals developed certain social kind of rules of interaction in order to survive, because it's easier to survive as population.
Did you see the movie about Bobby Fischer? Not a great guy, but I think quite clever.
Yeah.
I have to see that one.
But so to get back to Irina's comment, so you're saying these other things like ethical or moral forms of intelligence would follow up from, if we had compassion embedded, they will emerge. But what about
compassion itself? Yes.
What would you think, compassion can itself emerge if you don't even?
It can emerge. It's a natural survival property that emerges because you need it in order to survive as a population. So it emerged historically, right? Nobody imposed compassion on people or animals or mammals
from time to time.
Yeah.
We just need to figure out how to create proper environment for artificial systems, like what kind of capacities they should have, and what kind of environment and what kind of social interactions they should have to make this emerge. So think about that like there is a principle of Montessori school for kids, because depending what the kids will be exposed to, they will develop very different sets of concepts, skills, and attitudes toward life and everything. So if you put them in the proper environment, they will develop in the proper direction. You need to apply the same thing to artificial intelligence, like a Montessori approach.
Yeah, you're clearly living in Canada. That is.
So
I moved from US, and before that I moved from Russia. So it's not like I always lived in Canada.
So final words from Konrad.
Taken on a very heartwarmingly Canadian point of view.
Yeah.
So I was just going to point out that I think there's a reason why we have so much trouble with the word intelligence, because where it comes from, it's kind of one of the early principal components of humans. Like we all have that experience. There's some people who are good at multiplying numbers and are good at arguing about things and good about solving ethical problems. And this is an underlying factor that if you take lots of people's responses to all kinds of things, ends up being the first factor. But Now we take that word that kind of bootstraps out of us interacting with humans, and we apply it to the human-machine difference. Now, it turns out that the very intelligent people are really good at adding numbers as humans. They can maybe do like 3-digit additions. Now, 3-digit additions are like no problem for my mobile phone, but that's because basically it's one axis that just has lots of skills that are all correlated to it. So when we use intelligence in AI, we often mean kind of like the ability to match that humanness ability to reason well and act well and be ethical well and know what, like, have goals in life well. And we kind of mix that in as if it was the other one. And I think this confusion is what gives rise to a lot of the discussions we're having.
Yep. So there's another popular question that we have. Do biological feedback loops play a role in intelligence worthy of modeling in AI? Example, feedback loop from V1 back to the thalamus.
Yeah.
Okay, Konrad is not sure.
I don't
Everyone else
understand
says
the
yes.
question. I don't understand the question.
Do
Or do you not
biological
understand why it's a question? I mean, it's
Are you thinking like these sort of inductive biases that we take from the brain and we build into machine? Are they important? Is that the question?
No, the question is, are feedback loops necessary for intelligence?
Right.
Yeah.
Okay.
Absolutely.
Yeah.
Okay, hold on. Let me take the other side. I
Okay.
say no in that case.
Yes. Okay.
You
Let's
see,
let's hear it.
people
Let's hear it for the feed forward situation.
Okay,
Yeah.
so if we have a system that has feedback, we can always replace it with an equivalent system that doesn't have feedback. And in that sense, no, like
How? Wait. I'm curious to see what you mean by that.
okay, so if we have a recurrent neural network, not like it has a feedback loop, or I thought that's the definition of that. So
Yes.
if we have an on-end that solves a given problem, we can replace it with a convnet or something that can solve the very same problem. And in practice, the performances of these two systems are very similar to one another.
I'm
I
not
think
sure.
what's a bit different with brains is modularity, that as you go up to different parts of the brain, you form models at different levels of abstraction that then you can project down to back to the auditory system, visual system, decision making. And I do think that's not just, I mean, that would be an incredibly inefficient, CNN that you would then turn into a feed forward one. I think that, and that is probably what intelligence is. It's the ability to use very varied forms of information to come up with an abstraction that then is able to broadcast out to different regions in which that incoming information was not used. Right?
But we could have abstraction and non-recurrent system. No, let me I don't know where I'm on that side of the discussion we're having.
Right.
Like I just don't see that just because there's abstraction we can diminish the idea that recurrence is irrelevant.
But okay, but for me to play, to swing back the ball in Konrad's court, is most of the examples of these feed forward networks that can do the same thing or better than recurrent networks are, to my knowledge, not very scalable to a certain extent, right? You require to, like, think about transformers, right? You require to hold many things in memory to attend to it in a way that is somewhat constrained. And I believe that there's a lot of evidence that recurrence can be used to encode and to produce computations in a more compact way than just stuffing everything in a big sequence and then doing attention over it, right? This is not like scalable, and it's not necessarily practical in a way where you have flux of information and there's dynamics in the world we live in. Although there are tricks, I agree, there are tricks to adapt these things, but these tricks are not scalable. So in my view, I think if we think about recurrence, these biological feedback will have a great deal of potential to solve this idea of scalability.
Yeah. So a few more general questions before we wrap up. So do you have suggestions for people working in the field of neuro AI on what kind of subjects they need more training in? For example, maybe philosophy, maybe psychology, or what do you guys think?
I guess it depends on the background of the individual, if whatever they're lacking. But on a general level, I do think that it's becoming more and more of an interdisciplinary field, and we need to go beyond the neuro AI to go to other disciplines that actually involve neuro AI at different levels, but give us more perspective. So philosophy is an important one, absolutely. Psychology and cognition in general is an important one. So yeah.
Yeah, I mean, maybe this is easiest answered by sort of where do we come from and what do we feel we're lacking? So I come from physics, so I feel, I love physics tools, applied math tools. Where I feel I'm lacking is psychology, actually. I would love to have more training in good old-fashioned, cognitive science and psychology.
Yeah. And to build on this, I'm hearing reverb here. I'm not exactly sure where, but I believe it's important to stride towards bridging scales. Like for whatever your training is, I come very much as a similar background to Adrienne, and I've studied a lot of the biophysics and the dynamics of neural circuits, but now I'm actively pursuing more understanding in cognitive sciences and things that involve the scales of neural computation that are different. So I think one thing to keep in mind to have very truly impactful areas of study in future AI applications, I think, is to understand different scales of the brain mechanisms. Yeah.
Yep, Konrad?
So I think one important way of thinking about this problem is not like you can learn your entire life, and there's an infinite set of things out there to be learned. The question is, what's going to really prepare you for the career that you want to be at? So that's the first the question that I asked myself. The second one is about supply and demand. So science suffers if lots of people go through the same kind of training, because then lots of people do very similar things. And we can see the bad signs of that in say, AI research, where we have lots of papers that marginally improve, like some benchmark, together with complete bullshit math that's just there so that you look intelligent. And if everyone gets trained in that same background, then the problem is that the field gets more and more uniform. And that's why, say, people like Guillaume or Adrienne are contributing so much to our fields, because they kind of bring those skills from other fields. So wherever you find yourself, whichever corner you're in, I think the most interesting training is exactly the one that your field isn't currently listening to, which makes for a short period of massive suffering because everyone hates you for that, but it makes for a lifetime of actual contribution. So therefore, by all means, if you're in an area where people don't yet do ethics, bring in ethics. If you're in a field in which they don't have cognitive science, bring in cognitive science. Whatever that combination, but like you want to be different. You don't want to be part of that mass of people that all come with the same training.
And
yep, go ahead.
But I wanted to add sometimes one can achieve what Konrad is advocating in a combination of different fields that's unusual, right? It's not necessarily that you want to go against the grain and study how wood computes, right? But the idea of combining different pieces of this big sphere in a way that's quite unique is a way to get at the same goal, right?
And Karim and then Irina.
Yeah. Just for the sake of argument, I think one important thing is also, obviously, you always need to enjoy what you're doing. So it's not because you feel, well, I definitely have to do physics because this is the part that I'm lacking, and you hate it, and you're going to just spend 1 year doing something you love just because you think it's useful. So you need to get exposure to several things. It's like when you were confronting kids to different instruments so that they can identify the one they love and they want to go with. So I think we need to, and this is a part of our role, to make sure that there are these different, let's say, disciplines and topics that are brought closer to students from AI, from neuroscience, and that they have the opportunity to, even for a couple of months or weeks, or just maybe take a book and read it, identify or maybe fall in love with something else. And then they will do that because they really enjoy it. And then the added value is going to be huge because you're really excited about something new, as opposed to doing it just because you want it.
That answer. I do think a lot of why people do what they do is aesthetics, right? You do the thing, the type of work that you find joyful and beautiful, and you have to find that.
Irina,
I want to play.
Then, go ahead. Yep.
Okay. Okay.
Yeah.
I just wanted to add a little something, like play devil's advocate here, because I do believe that there's a set of core skills that are based in physics and mathematics that require more just a year of something and a year of, like, there's a level of proficiency that's important to acquire in these quantitative fields that might not feel like it's enjoyable, right, to a certain extent, but there's a baseline, is what I'm trying to say, in these very historically rich fields that I think should not be snuffed on just because it's hard or it might not be enjoyable at first, right? That's important to.
Fair enough.
Yeah.
Yep. Irina, did you have some thoughts?
Yeah, I just wanted to comment. Yes, so first of all, I completely agree about the need for interdisciplinary kind of angles. So you do want to look at various disciplines which in different forms studied the question what mind is. And that includes, of course, philosophy, it includes biology, it includes, of course, neuroscience, it definitely includes psychology, psychiatry, and so on and so forth. And you can even think about, well, Surya gonna probably laugh at me right now, but I'm a big fan of Buddhist philosophy, because those guys essentially developed an empirical science of mind that existed for several thousands of years, and even many neuroscientists are not too aware of that. Forget about AI people. And I think those disciplines, even not everybody treats them as disciplines, they just accumulated a wealth of empirical knowledge about pretty much how this software works, what is a library, what are the subroutines, and what kind of inputs you need to provide or not to provide in order to run them in certain ways. So there is like lots of stuff there. So this is one point, interdisciplinary. And the second point, even within like modern disciplines, I keep noticing trend among many bright young students. What kind of papers they look at? The ones that are most recent. If the paper is from 2018, it's so yesterday. And what I want to say, maybe you should read the classics, which is, I don't know, how many people have read Shannon's Mathematical Theory of Communication in AI field?
I haven't.
Well, yeah. Among young students, how many people read the original Turing paper? Some did. Some did. Many didn't. So bottom line, my advice is, it's very interesting to follow the most recent developments. It's extremely exciting. It's highly dopamine inducing because it's very recent, but you need to read the classics also. Like the machine learning before deep learning, for example, right? Vapnik, statistical learning theory, and so on and so forth. So maybe it's a role of us professors to help students to go back to classics and sometimes have that reading list. But otherwise, we are all, as what they say in continual lifelong learning systems, people in machine learning suffer from catastrophic forgetting.
Yeah.
You don't want that.
Well said. Well said.
Yeah.
Maybe one point I'd like to add to this, because I think it's a very important question for the students that are asking these types of questions. And I think it's important to realize that not all students have to become bilingual, let's say, or trilingual or multilingual in all these different disciplines and actually master them 100%. Some, and this is also part of what we try to do, is to provide opportunities for some to become bilingual, so be equally efficient and understand, converse in neuroscience language or also in AI. But for many cases of applications, what you need is to understand what the collaborators, the people that I work with in neuroscience mean when they talk about memory. So you need to develop a skill of understanding the language, getting close enough. It doesn't mean that you become a neuroscientist and an AI researcher at the same time, equally at 100% of your time. Some people might want to do that, and some people are doing that currently and doing that brilliantly, but that's not necessarily what everybody should do and what all students should aspire to. Some are brilliant in AI, and they need to get sufficiently close to understanding the language used in neuroscience, the problems that neuroscience scientists face, to be able to collaborate with them. They will not be running the experiments, but they want to be working with people running the experiments to answer new and important questions, and vice versa is true too. So I think it's a distinction to keep in mind.
That is good advice. But I mean, this is a great discussion, but I'm forced to wrap this up because Adrienne has her talk coming up. So thank you all. This, especially the last part, was very informative, and it was really cool listening from all of you. And everyone, we will give Adrienne about 10 minutes before she can and you can get back, and Adrienne will be presenting